students. I'm called Daniel Pura. I'll be taking you in vector calculus. So I hope that you have the course outline, whereby we're having vectors and scalars as the first part. Then we have the second topic as the dot product and post product. The third topic as vector differentiation. Then gradient, divergence and curve. Then we also have vector integration. And integral theorems. So for today specifically, we are going to deal with vectors and scalars, and then the dot product and the cross product. So first of all, we have to know what a vector means and what a scalar means. What a vector means and what a scalar means. So a vectors and scalars are both quantities, okay? For example, a vector is a quantity which is described by both magnitude and direction. A vector quantity is described by both magnitude and direction. Therefore, a scalar, we describe it by only the magnitude. Describe by only the magnitude. Then we shall go directly to the dot and cross product. Dot and cross product. Let's deal with the dot product. So for example, if I give you a vector x, which is 3i plus 4j plus 2k, and I give you a vector b, which is 2i plus 6j plus 2k. First of all, what we mean by these letters? I, j, and k. I, we have the Cartesian plane, whereby we have the x-axis, we have the y-axis, and we also have the z-axis. This is our x-axis, this is the y-axis, and then this one is the z-axis, okay? So when we say that 3, this value 3 lies on the x-axis. Then when we say that 4j, that means this value of 4 lies on the y-axis. Then if you say that 2k, that means that value of 2 lies on the z-axis. Now if we go direct, we have to solve this, and then they tell us if I ask you to find for me A dot terms of what you have to know first is I dot I equals to 1. J dot J also equals to 1. And K dot K also equals to 1. Okay. I dot I equals to 1. J dot J equals to 1 and K dot K equals to 1. So now let's work out our number here. We shall be having 3I plus 4J plus 2K dot, this is our A, dot B, whereby B is 2I plus 6J plus 2K. We are going to be dotting. When you are dotting, you dot those ones in I with those you dot the value in I with the value in I, and then you dot the value in J with the value in J. You also dot the value in K with the value in K. So from here it will be 3I dot 2I. 3I dot 2I. Let's do our side one. Okay, we shall be having 3I dot 2I. So here it will be the same as 3 times 2, or 3 dot 2. Okay, then I dot I. I dot I. 3 dot 2 is the same as 3 times 2. 3 times 2 will be giving us a 6. Then I dot I is 1. I dot I is 1 as we have talked about it previously. Then 6 times 1 is the same as 6. So now from here, 3I dot 2I we shall be having a 6. Because if we dot I with I, we shall be remaining with 1. And 6 times 1 is the same as 6. Then 4J dot 6J, we shall be having 4 times 6 is the same as 24. Then J dot J is the same as 1. That means now we shall have eliminated the J. 2K dot 2K, it will be the same as 2 times 2 is 4. K dot K, that's 1. That means now we are going to be remaining with 4. Now 6 plus 24, we shall be having 30. 30 plus 4, that one will be giving us a 34. So now here we are going to end up concluding that A, the vector A dot the vector B is the same as 34. So in case you have any question, you can WhatsApp me on 0794 for the 788. Then we are going to do another example, and then we go to cross product. So if they give us a vector Q, which is 2I minus 3J plus K. And then they also give us a vector P, which is 6I plus 6J minus 2K. Still it is the same issue. We want the dot product of we want the dot product of vector q and vector t. That means it is the same as q dot p, which equals to, we'll be having 2I minus 3j plus k dot 6I plus 6j minus 2k. Now we open the brackets. 2I dot 6I, we shall be having 2 times 6, that is the same as 12. I dot I is 1, okay? That means we shall be having eliminating the I. Negative 3 times 6, a negative times a positive, we get a negative. So here it will be negative 3 times negative 6, we shall be having negative 18. Okay? Then here we are having only k. That means now we have some hidden 1 here. Okay? It is the same, k is the same as 1k. Okay? So now it will be 1 times negative 2k. 1k times negative 2k. We shall be having, that means this is now 1 times negative 2, which will be giving us a negative 2. Then from here, negative 12 minus 18 minus 2, which will be giving us a negative 8. That means the dot product of Q and P is -8. Then now let's go direct to cross. Let's go direct to cross product. So for cross product, we normally use the symbol, which is almost the same as the multiplication sign, okay? Which is almost the same as the multiplication sign. So directly I'm going to go to examples, okay? For example, if I tell you if we have two vectors, if you have a vector A, which is xi plus yj plus zk, and then we have a vector B, which is x1i plus y1j plus z1k, and then I tell you to find the cross product of A and B. Find the cross product of A and B. So from here, we shall arrange those ones in I, and those ones in the Z direction, and those ones in the K direction. So let's begin extracting out from the vector A those values in the X, those values in the I, J, and K direction. So now in the I direction we have X here. In the Z direction we are having Y. In the K direction we are having Z. Then for vector B, in the X direction we are having X1. In the Z direction we are having Y1. and in the k direction we are having z1. Okay. So when we are finding the cross product, okay, what we do initially, if you want to get the value in the I direction, you have to close these values in the I, and you also close this other part. So from there we are going to look for the determinant. I hope you will have some knowledge of matrices. When you are looking for the determinant, you are going to cross multiply this one, and also with this one. As you get there, they are different. So from here now it will be, we shall be having y times z, which is the same as y z1, y times z1, which is y z1, minus z times y1. Then outside we are going to be having the symbol for the I, for I direction. Then from here we should not forget that here this is positive, then this one is negative, and then this is positive. So now here the next sign will be minus. You close the brackets. Now when we are going to look for the values in the z direction as you are closing, now we shall close this side, and we also close this other upper side, and then we look for the determinant. That means will be the determinant of the product of x and z1. Then we also look for the determinant of the product of z and x1. So it will be x, z1 minus z x1. Then we remember now we are dealing with the z direction. We put z out. Then the next part is positive. That is now it will be plus. We do the same thing. We close this part and also this part. Then we look for the determinant, which should now be x y1 minus y x1 minus y x x1. So this is the general formula for cross product. Let's go to a practical example. If I give you a vector A, which is 2I plus 3j plus k, and I also give you a vector B, which is 7I plus 2j plus 2k, and I tell you find the cross product. The cross product is going to be A cross B. We follow the same steps. This is I, J, K. Then the values here we are having 2. Here we have 3. Then here we are having 1. For B we have 7. We have 2. And we have another. So when you're looking for that value in the I direction, you close this part and also this, but then you look for the determinant of the product. Okay? So now it will be bracket 3 times 2, which will be giving us a 6, minus 1 times 2, which gives us 2. We are dealing with the I direction. Don't forget that here it is positive, here negative, and then here positive. Now to be minus bracket, we close this part of J and also that upper part. That means now we shall be having 2 times 2, which gives us a 4. Then 1 times 7, which gives us a 7. The direction is Z. Plus, you should put in consideration of this side. Bracket, you close this part and also you close this other part. So now here it will be 2 times 2, which gives us a 4, minus 3 times 7, which gives us a 1. The direction is K. So 6 minus 2 will be giving us 4. But remember what we are having an I. That's why now that means it will be 4I minus 4 minus 7 will be giving us a negative 3. As it will be negative 3. Then Z. Then 4 minus 21 will be giving us 17. So now here we're going to be having, remember that it is a negative, you should not forget the negative, we shall be having negative 17. Okay. So from there, we shall end up getting 4I. A negative times a negative will be giving us a positive. So now here it will be now plus 3Z plus, is it a plus or negative? It is a negative because a positive times a negative will be giving us a negative. I think we shall end up getting negative 17, okay, as our final answer. So we shall start there from. So we shall start from there.